Hello, this video is on conservation of momentum. The picture on the left is of a Newton's cradle. This is a classic example of conservation of momentum. We have this ball here which swings down and hits the next ball along. Momentum is transferred through all of these balls until the last one swings up. And if you're in ideal physics land with no friction or no air resistance, this ball here will receive the same amount of energy as the original ball had, and it will swing up to the same height. In an isolated system, the total momentum is conserved. In stage 1 physics, you need to be able to use conservation of momentum to solve problems in a variety of contexts. So we'll start off with some definitions. A system is a portion of the universe being analysed. It sounds a bit vague, but it's whatever portion you're specifically focusing on. So it could be a pair of pool balls that are about to collide on a pool table. It could be like a rocket taking off from Earth, so the isolated system will be the rocket and the Earth. It could be our entire solar system. It's just whatever you're specifically focusing on. An isolated system is a system that is free from external forces. So for example, if we're talking about our two pool balls, if we're only talking about those, then friction would be an external force to those pool balls. Another external force could simply be whacking the balls with a pool cue as they collide or before they collide. That's an introduced force, and it's neither the first or the second ball, so it's an external force. The law of conservation of momentum states that in an isolated system, the total momentum before a collision equals the total momentum after a collision, and that's represented by this rule here. So total momentum before a collision is equivalent to the total momentum after a collision, and therefore it's both of those separately are equal to the total momentum of the system. So in our billiard balls or pool balls example, they're about to crash. So the total momentum of this system is going to be equal to the momentum of ball A plus the momentum of ball B. So that's expanded out as the mass of A times the velocity of A plus the mass of B times the velocity of B. Both balls exert a force equal in magnitude and opposite in direction on each other, as per Newton's third law of motion. So writing this out, that'll look like force A is equal to negative force B. We know that force is equal to the change in momentum over the change in time, or the rate of change of momentum. So the rate of change of momentum for ball A is going to be equal to the rate of change of momentum for ball B when they collide. When they collide, obviously the time that they collide for is going to be equal, because it couldn't be longer for one if it's not the same for the other, because they're both touching each other. So that means that, that should be negative there. That means that the total momentum of ball A is equal to the total momentum of ball B, because those two times can just cancel out. That therefore means that total momentum of ball A plus the total momentum of ball B is going to be equal to 0, because if we add the change in momentum of ball B to both sides in this equation here, will cancel out this side and we'll be left with 0, and we'll get this side plus change in momentum of ball B. So this is mathematically saying that the changes in momentum of each ball are equal and opposite, because if you add them together they equal 0. So a worked example, we've got two 160-gram billiard balls and they're about to collide. One ball is travelling with a velocity of 2.4 metres per second to the right, so that'll be this one here, 2.4 metres per second. And then the other has a velocity of 3.6 metres per second left, so that'll be this one here. After the collision, the first ball has a velocity of 1.6 metres per second to the left, and we have to find out what is the final velocity of the second ball. So 1.6 metres per second. There's two ways that you can do this. I'm going to show you both. I personally prefer the second way, but whatever way works best for you is absolutely fine. The first way that you might do this is by finding first the total momentum of the system. So P, or momentum total, is equal to the momentum of, or the initial momentum of ball A plus the initial momentum, of ball B. This will be equal to the mass of A by the initial velocity of A plus the mass of B by the initial velocity of B. So this would be 0.16 kilos, so 160 grams to kilos, by, we'll say that right is positive and left is negative, so 2.4, and then plus 0.16 by negative 3.6. This will be equal to negative 0.19 kilogram meters per second. So that's our total momentum of our system, or 0.19 kilogram meters per second to the left. So we've worked out the total momentum. Now what we have to do is work out the final momentum of ball B. To do that, we'll still use the same rule. P, or momentum total, is equal to momentum A, but this time A final, plus momentum of B final, which will rearrange to momentum of B final equals the total momentum minus the momentum of, or the final momentum of ball A. So then this will be negative 0.19 minus, and then our mass of A, which is 0.16, and then our speed of A, which is 1.6, or our velocity of A, which is 1.6 meters per second to the left. That'll be negative 1.6. And then if you pop all of this into a calculator, you will end up with 0.066 kilogram meters per second, and because it's positive, that's to the right. Then the final step of this way, I might write it in a different colour, is working out the velocity of, or the final velocity of B. So to do that, we know that the final momentum of B is going to be equal to the mass of B multiplied by the final velocity of B. That means that the velocity of B is going to be equal to the momentum of B divided by the mass of B. velocity of B will be equal to the momentum of B, 0.066, divided by its mass, which is 0.16, and then that will mean that the final velocity is 0.41 meters per second, and that's positive, so it'll be to the right. So this ball here is travelling to the right at 0.41 meters per second. So that's the first way you can do it. To be honest, I find it a little bit more time consuming, so I'm going to show you my preferred way. So with my preferred way, we'll say that the total momentum initially will be equal to the total momentum, or the total final momentum. So that means that the momentum of A initially plus the initial momentum of B will be equal to the final momentum of A plus the final momentum of B. Therefore, the mass of A plus the initial velocity of A plus the mass of B by the initial velocity of B is going to be equal to the mass of A plus the final velocity of A plus the mass of B multiplied by the final velocity of B. So that is just saying that the total initial momentum is going to be equal to the total final momentum. We're just writing it out all in one equation. We are looking for what this is going to be, so the final velocity of B. So we can rewrite this entire expression as the final velocity of B is going to be equal to the mass of A by the initial velocity of A plus the mass of B by the initial velocity of B minus the mass of A over the times the final velocity of A, and then that's all divided by the mass of B. So hopefully you can see I've rearranged this equation, first by minusing, I'll get a different colour, first by minusing this whole term from both sides, so it appears to go over to the other side of the equation, and then I just divide everything by the mass of B in order to get the final velocity of B by itself. Because the mass of A is equal to the mass of B, we can cancel out all the m's because they're the same. So this, and this, and this will all cancel out. So in order to find the velocity of B, or the final velocity of B, we'll just be left with having to add the initial velocity of A, the initial velocity of B, and then minus the final velocity of A. Once we do that, we'll end up with the velocity of B being 0.4 meters per second to the right. And this will be slightly more precise, I'll say, compared to the previous answer. We've got 0.41 meters per second here versus 0.4 meters per second. And that's because we've cancelled all of our terms out before subbing in our values, and that means that there's less rounding error carried through the you're working out basically. I'm not going to take marks off if you do this way versus if you do this way, because the physics is obviously fine, but mathematically this one would be slightly more precise or accurate. But yeah, up to you which way you prefer. I personally think this way is easier, or even just less time consuming. I suppose the equations are a little bit longer, but hopefully it's not too full on. Anyway, up to you which way you choose. Alright, so another worked example, we've got two vehicles that are being safety tested as per the schematic below. Calculate the total momentum of the system before the collision. So we've got one vehicle travelling to the right at 18 metres per second and its mass is 1200 kilos. The other vehicle is travelling to the left at 15 metres per second and its mass is 1300 kilos. So the total momentum before the system is going to be the momentum of vehicle 1 plus the momentum of vehicle 2. So total momentum equals P1 plus P2. This is going to be mass 1 by velocity 1 plus mass 2 by velocity 2. So that will be, I might zoom in for this, 1200 by 18, which is the 18 metres per second, and then 1300 by 15. This will end up being 2.1 by 10 to the 3 kilogram meters per second, and I forgot to say, but we'll take positive as rightward and negative as leftward, so that should be a negative 15 meters per second for the second vehicle. So the overall answer is positive, therefore the momentum will be to the right. The next question is saying that the vehicles stick together post-collision, forming a single mass. We need to calculate the magnitude and direction of their velocity after the collision. So to do these kind of question, it's the same, but you just add the masses together, and because they're forming one mass, the momentum of that overall blob, I suppose, or that overall mass of crashed car is going to be the same because they're connected. So in this situation, this will look like total momentum equals mass 1 plus mass 2, which will be the total mass of the collective crashed car, and the velocity will be the same as well. Obviously, because the momentum is the same, the velocity is the same, they're the same blob, so they're going to have the same physical properties. So we want to find the velocity, so we'll rearrange this, and this will just end up being the total momentum divided by both of their masses. This will be, will I run out of space? No, I'll just write it here. 2.1 by 10 to the 3, and then divided by 1200 plus 1300. Pop it all into your calculator and you'll end up with 0.84 meters per second to the right. So that's your final velocity of the overall mass. I might get you guys to have a go at this question by yourselves or in the first bit of class, just to see how you're thinking about these kind of questions, and then we can go through it together, and yeah, I might put up a video up afterwards. So have a think about this one. A bullet is fired from a handgun that is initially stationary. the mass of the handgun is 4.8 kilos, and the mass of the bullet, I forgot to put an M there, that was just meant to be MB between those commas, is 0.01 kilos. Calculate the total momentum of the system before the gun is fired. So to calculate the total momentum of the system before the gun is fired, you need to think about what the velocities of the bullet and what the velocities or the velocity of the gun is or are when the handgun is stationary. And then the next part of the question is saying that the bullet moves at 370 meters per second to the right after the gun is fired. Find the magnitude and direction of the gun's final velocity, assuming the system is isolated. So all I'll say about these ones is just make sure that you've got a coordinate system. So is to the right positive, is to the left negative, do you want to do it the other way, whatever. But yeah, that's, I guess, a hint for attempting this question.